Okay, so what we want to do is we want to continue discussing this really what we were trying to do is distinguish between nominal and real gross domestic product. We've sort of got a little bit of a mathematical calculation to go through here. These are the numbers I put on the board last time. What we had was 5 different goods, A, B, C, D, E. Then we have 2 different years that we're interested in, year 1 and year 2. So suppose, and this A, B, C, D, E, that's all that our economy produces, and what we've got here is the number of units of each good produced in year 1. You'll notice over here that we've got quantities for year 2. Let's just kind of eyeball those and see that for good A, production went up from 1 to 2, and it went down for product B from 20 to 15 units, down a little bit in product C, up a little in product D, and the same for product E. So what we have is kind of a mixed bag there. Some things we're producing a little more, and some things we're producing a little less, and some things we produce the same amount. And under the circumstances, what you might be wondering is, gosh, is this economy stronger or weaker in year 2 than it was in year 1? Like I say, some things were producing 50% more, and then what we had some things here where we went down. Is the economy stronger or weaker? Well, the way that we answer that question, is the economy stronger or weaker, is we ask about real gross domestic product. First of all, this is gross domestic product, GDP, in year 1. That's just nominal gross domestic product. That is to say, we just take all the goods, all the quantities, and multiply them by all the prices. For any given year, I'll put a 1. Oh, I did put a 1 next to there, didn't I? And that says for year 1, the contribution to gross domestic production of each good is shown here, and we add them all up. And this sigma sign, it's not a very good sigma sign, but this sigma sign, that's the sum of all these items, is $150. So gross domestic product in year 1, $150. It's the value, the market value of all new production of goods and services. Okay? In year 2, what we have, well, we sort of have a deal like we had with production, where we had quantities, some of them were higher, some were lower. What we have here is some prices are higher. Here's the price of good A went from $1 to $2 from year 1 to 2. Some other things went down in price. Here's something, good E, that was $3 in year 1, and now it's $2 in year 2. Some things prices went up, some went down. If we want to come over here and calculate gross domestic product, again, nominal gross domestic product. I'll just kind of write nominal up there. And when I say nominal, I mean that's just the market value, or the current prices without any further adjustment. We just use the prices we observe. But we've got the prices and the quantities, and we multiply those together, and they all add up to $180. Let's do a calculation real quickly. What's the percentage change in GDP? This is, and by the way, it's almost always, depends on who you're talking to, but for most people, if they say GDP, they mean nominal. And the only way they mean real is if they say real. But the percentage change in GDP, that's the change in GDP divided by the original GDP. The change looks like $30 divided by the original of 150, that was GDP in year 1. So what we get is 0.2 equals 20%. That's just the percentage change in nominal GDP. And that is a big change, by the way. Normally what we would expect GDP to do, this is really 2 things. It includes the effects of real growth in the economy, that is to say changes in the Q, production, the quantities. So that reflects, the changes in GDP reflects changes in the Q, the quantities produced, also the changes in P, the prices that we charge. So normally what I would expect is the real component of GDP to grow by 2 or 3% a year, and then nominal component, whatever the inflation rate is, but that might be 2% a year. So what you'd normally expect is 4 or 5% growth in GDP. Here it's 20%, so that's a huge number. Anyway, now we want to talk about real GDP. Here's what real GDP says, or tries to answer. How much is GDP in year 2 if prices hadn't changed? How much is GDP in year 2 if prices hadn't? That would be real GDP. Okay? It's real GDP for year 2 is the amount, the value of production in year 2, but just keeping prices where they were in year 1. We'll talk about that again in just a second. So what we have now is P1 times Q2. Look and see what that formula says there. GDP in year 2, well, that reflects the amount of production, the quantities that we produce in year 2, but we're going to leave prices at their P1 level, their year 1 level. So let's just go through and multiply the price in year 1 times the quantity in year 2. What do we have here? $15, $1 times 15 units. That's for good A. Good B, we have 2 times 15 is 30. Good C, 1 times, what do I have, 25 is 25. Good D is $2 times 25 is 50. And good E is $3 times 10 units is 30. We add these up, what do we have here? 45, 70, 120, 150. Is that right? Yeah, those, I'll go up this time. 80, 105, 135, 150. And the answer is, gosh, GDP is the same in year 1 and year 2 if prices stay the same. That is to say, if we had not had any inflation, if prices remained exactly the same, inflation, remember, is a rising price level. If we did not have any inflation, prices just remained where they had been, and all that happened in year 2 is we just produced new quantities. That tells us the real GDP in year 2. And what we see here is real GDP in year 2 is exactly equal to GDP in year 1. There was no growth in this economy. The economy did produce more of certain things. For example, and we've already said this before, but product A, we got 50% more of that. But there's other things that we produce less of. What was one of those? Product C, we went down from 30 to 25. Okay, so, and product B, it looks like we went down from 20 to 15. So, in general, we had some growth in some sectors of the economy and some contraction in other sectors of the economy, and our overall economy is producing the same amount of real gross domestic product. Questions about this? What's the chances of that happening? I swear I just made those numbers up as I was going the other day. Put them in there, and they all were. I was kind of interested to see if real GDP went up or down myself because it was a mixed bag. And so the answer is it didn't change. Any questions about this? Let's pretend just for 1 second, just so we can do another calculation. Let's pretend that real GDP had gone up to $160, then we could have done a calculation. Percentage change in real GDP would have been, there's a change in real GDP would have been $10. The original is $150. So then the growth would have been about 0.067 equals 6.7%. I better get the calculator out. $10 divided by 150. I didn't need the calculator. What can I say? Anyway, that is if we had had some growth. The only reason I put this 160 in is just to give us an opportunity to do a calculation. I've got my notes here is calculate percentage change, so I thought I'd do that a couple times. Anyway, but the numbers that we have here just tell us the economy did not grow. Okay, look, if the economy didn't grow, the reality is this is 150 The reality is this is a 0 and that is a 0. If the economy did not grow from year 1 to year 2, and I mean did not grow in this quantity sense, then how is it that nominal GDP went up by 20%? And the answer is prices went up. There's two different components to our GDP. GDP equals P times Q. And this is all of the P's times all of the Q's. I'll put that sigma sign up there to mean we got to multiply them and then add them together. But the point is that when we're calculating gross domestic product, and that's got two different parts to it, two components. One component of gross domestic product is the prices, the market valuation, and the other is the quantities we produce. And I'm saying if GDP goes up by 20%, and if Q goes up by 0%, that is to say it doesn't go up at all, there's only one way for GDP to have gone up, and that is to say that price variable, it rose by about 20%. You with me? It's the same thing with you or me. My income could go up. Like last year I earned $10,000. This year $11,000. Okay? But even though my pay has gone up 10%, that could have been due to an increase in the value of what I produce. You know, I'm producing more this year than last year. 10% more? I don't think so. The other possibility is that it was an inflationary price increase or wage increase in this particular case. So it's those two components. Let me throw up another term here that now that we've got all these sort of real and nominals straight, we can talk about the GDP deflator. GDP, I'll call it a price deflator. And I'm going to use this kind of a funny looking P there to be that price deflator. You know, I need something else to write with. Equals nominal GDP over real GDP times 100. This GDP price deflator, you can think of this as the price index for GDP. You remember we already talked about a consumer price index. The consumer price index was an index of consumer prices, and that's why they call it that, by the way. Anyway, the consumer price index was an index of consumer prices, and what we did is we had the consumer's market basket and we put prices on it and priced that basket over time. This is another price index. It's a broader price index. The consumer price index that we've already talked about before, that consumer price index, it looks at the cost of consumer goods through time. This is not the price of consumer goods through time. This is the price of everything through time. Every new good and service, not every single one is included in here. Yeah, I guess it is too, though. Every new good and service has its own entry into this nominal and real GDP, so every particular good and service has the ability to affect this GDP price deflator. And so now, let me write something down here. Here's nominal GDP. Let's talk about, we had year 1, year 2, and by the way, well, let's talk about year 1 and year 2. Here's what we'll do. Here's nominal GDP in year 2. I'll put a 2 there. Nominal GDP in year 2 is equal to P2 times Q2. And then that big sigma sign out there. Real GDP in year 2, and these are both for the same year. Real GDP for year 2 is this. It's P1 times Q2. Times 100. Now, this is not really legal mathematically to do, but I'm going to do it anyway because I'm kind of a renegade mathematician. If you think about those Q2s canceling each other out, the one in the numerator and the one in the denominator, what you can see is that this price deflator, it's kind of P2 over P1. Hey, that's kind of what I was looking for. I want to know how much higher is P2, our prices in year 2 than they were in year 1. Questions about this? Now, let me see if I can't get us a number here and, you know, something from the survey of current business, something that is a little bit more up to date, a little more real. I shouldn't say real in that sense. A little more realistic. What do we have here? Oh, I know. I gave you some numbers the other day. If you remember when I went through, I had GDP up here, and then I had consumption and investment and government spending and net exports, and I put amounts of money up there for each one, if you remember. And then I said the total is, I can't remember if I ever gave you the total, but let's write one down. $7,566.5 billion. I'm just looking at this for, what year was that? 1998. That was actually, when I gave you those numbers, that was actually real GDP. I don't know if I told you, you may want to look back in your notes and see how we labeled that at the time, but that was real GDP when I was giving you those numbers, and I can't remember if I gave you this specific bottom line figure or something close to it or what, but anyway. So we've got real GDP for 1990, what year was that for? 8, was $7,566,500,000,000. Okay. Then, the other day, we went through the compensation of employees and the rent and the interest and the proprietor's income and the corporate profits and so forth. And I gave you real GDP again. Let me track that down. Boom, 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 boom. This is interesting stuff, just no matter how you slice it. There it is, there it is. So then another time I gave you nominal GDP, and that was where we had the wages plus the rent, plus the interest, and the profit, etc. And those all, and that was nominal GDP. And that was also, I think, for the same year, 1998. And the amount, what do those all add up to? Well, it wasn't just those, but then we had to go through and the indirect business taxes and the depreciation, capital consumption allowance, and so forth. But anyway, under that method of measurement, GDP, now where do I see that? This is fascinating stuff. Just numbers, numbers. 8538, there we go. $85.38 billion. Sorry to be so slow with that, but I wanted to use some actual numbers. Here's what we've got, is we've got, for the same year, 1998, we've got two measures of GDP. One of them is real, one of them is nominal. So what we'll do is we'll divide the nominal, the 8538 by 7566. Those are both in billions of dollars. And I'm saying that's times 100. That should be the price index for 1998. Let me get the calculator out. 8538 divided by 7566 equals, oh, times 100, equals 112.8. 112.8, meaning what? Yeah, good question. Meaning what? The price level in 1998 was 12.8% higher than it was in the base year. That is to say, in the year when we started counting forward, and what year would that have been? I believe that is in 1992 dollars. Prices 12.8% higher in 1998 than in the base year. I'll talk about that in just a second, of 1992. Again, I'm sorry that that's not writing better, but we will talk about the base year in just a second, but we're saying that prices are now 12.8% higher than they were, it would have been 6 years before. Now, what do I mean by the base year? And the base year is just arbitrarily chosen. It makes absolutely no difference. In our story over here, we had our base year was our starting year of year one. And so then when we came through here and calculated our price, oh, maybe we never did calculate that price index. I guess we didn't. What's this? Nominal divided by real. What do we have here? Nominal GDP is 180. Real GDP, we'll call this our base year, is 150 times 100. This is equal to 1.20, 120. You got to multiply by 100. The interpretation of this is prices are 20% higher in year two than they were in year one. So it's always on a comparison basis. What's happened to the price index since the base year? Our base year was year one, but for the for the gross domestic product, when they measure real GDP, they use 1992 prices. Well, let me come back and modify this just slightly. We could say these were 1992 prices, 1992 quantities. This would be 1992 nominal GDP, and then we would have switched over here to 1998 quantities, 1998 prices, and then a 1998 nominal GDP. And I'm only trying to make it comparable to what we have over there. And then this would have been 1998 GDP evaluated at 1992 prices. So all we're really doing is we just pick a period where is our beginning point or our base period for this, and then all these other calculations are just what we see right here, where we're basically cranking through, doing the math. The hardest thing about this is not the math. That's pretty simple. The hardest thing about it is sort of keeping it straight, what your objective is, what your ultimate goal is. Took me a moment ago when I was trying to realize or think about what do I want to do over here. So it takes you a second to just kind of put all the pieces together. But we had these numbers already calculated. Nominal GDP in year two, 180. We had already calculated the real GDP in year two, so then it was a matter of going through and doing this and talking about our 20% increase in the overall price level. Anyway, there's quite a bit up here. I think that if you wanted to focus on something, you should be kind of comfortable with doing one of these calculations. This might be something I give you on a test. I might say something like, the following four goods are in the economy. Here's the quantities produced in the base year. Here's the prices in the base year. Here's the quantities produced in the current year, this year. Here's the prices in the current year, this year. And now, how much is GDP in the base year? How much is GDP this year? How much has been the percentage change in GDP? Well, it's real GDP, but those same types of things that we've done right here. And also those are the things that are in your textbook. Okay. Questions? No. Okay, well, let's go on. I've got just a few more measures of economic activity that we want to talk about, macroeconomic activity. We've talked about gross domestic product. Let's talk about, we are already done with that one. Here's the next one, net domestic product. NDP, net domestic product. The only difference between gross and net domestic product is just that first word, gross versus net. Huh. See, if anybody had explained it to you that way before, you would have already known what this is. What's the difference between gross and net? And the answer is this. Gross domestic product minus the CCA, that's capital consumption allowance. That was one of the things that we talked about last time. Another word for this is depreciation. But the idea is the final value of all new goods and services, that's GDP, minus the capital goods that got worn out during the year. If you produce goods during the year, let's say a value of those goods, you produce $8 trillion worth of goods during the year, but then if you wear out, just hypothetically, $500 billion worth of capital goods, then you first have to replace those to get back to your starting point. So you take $500 billion to replace the capital goods that wore out, and then you're only left with $7.5 trillion worth of goods and services to be consumed after you've replaced the capital goods. And so that's what we see here is, this is the value of economic production after we replace the goods that wore out during the year. Some people think that's a better measure of economic activity, net domestic product, better measure of economic activity, because why count GDP if you had to wear out some capital goods in order to get that GDP? You first have to replace those capital goods, get yourself back to where you were at the starting point. And after you've replaced those, then GDP, all you have left is NDP, letters. So, net domestic product. And the difference between the net and the gross is the worn out, the capital equipment. Questions? How about this one? Personal income. Oh. Just a second. There's one I want to talk about before personal income, then we'll get to personal income. National income. We've already talked about this, that's why I skipped it, but we didn't really give it a name, I don't think. This is equal to compensation of employees plus proprietor's income plus corporate income, or let's say corporate profits, plus rental income, plus, what was the last one? Interest, or net interest, wasn't it? The other day, when we were talking about the income approach to calculating GDP, we went through these 5 items, and those add up to national income. National income, if you want a definition, national income is the income of the factors of production, or the productive resources used in the economy. How much do we pay workers? How much do entrepreneurs get? How much do property owners who rent it get? How much do people with capital to lend, how much do they get? So you add up the income of those. It's really 4 different sectors, but there's 5 items that you add. The proprietor's income and the corporate profits are both returned to entrepreneurs. But you add all those up and you get national income. Income of the factors of production. Now, personal income. Personal income we could define as income received from all sources whether earned or not. But you have to receive it. Let me just add that word right in there. Income received from all sources. Whether you earn them, whether you don't earn it, it's just received, so we call it personal income. Now, what does personal income equal? First of all, the first source of income is national income, which we just talked about, but the compensation of employees, the rent and the interest and the profits and so forth, those things are a national income, and that is the biggest part of personal income by far. Then, but you have to receive it, so we're going to start subtracting income that we did not receive. We do not receive undistributed corporate profits. That is, if you go back here to what's in national income, one of those things is corporate profits. And we included total corporate profits. But now we're coming back and subtracting out that part of corporate profits that we don't receive, we in the households. Corporations don't pay that out to us, they keep it. Okay? Here's the second thing we subtract out. Social Security taxes paid by employers on your behalf, on workers' behalf. Sometimes you'll see this described in a slightly different way, social insurance taxes and so forth. But the idea is this, is that your employer is paying out some money, and let's go back to the first item here, is compensation of employees. That was in national income. There were other things, but anyway, total compensation of employees. Your employer pays you some wages, but your employer also gives you some fringe benefits. One of those is sending money into this government retirement system, this Social Security system. Okay? So when we talked about the employee's compensation and putting it in national income, that includes what your employer pays into the Social Security system. Now what we're saying is, yeah, I'm not interested in what the employer pays in on my behalf. I want to know, what do I come home with? What do I get? And the answer is, well, you don't get those Social Security taxes your employer pays. So we'll subtract that from national income. A third thing, corporate profits taxes. That's part of national income. That is to say, total corporate profits were included in national income. But some of those corporate profits, the household sector doesn't get. Some of those corporate profits get sent off to the government. So that's national income that never is received by households. And finally, we add one in, transfer payments. I think I've used this term once or twice before, but maybe you're unfamiliar with it. Let me describe it for you briefly. Transfer payments, those are payments that come to a person in exchange for nothing. It's, in a sense, a gift. But the person who receives the money doesn't have to hand anything back in return. An example of that would be, well, that might be like my paycheck. But the government doesn't think that I'm doing nothing, so they wouldn't call it a transfer payment. But like if I got a Social Security benefit, that would be where just at the end of the month I just go, I get the check. Oh, I guess it would be at the beginning of the month. Thank you very much. But I don't have to go to work. I don't have to do anything. There's just this money coming in the mail. Unemployment compensation would be another example. Now, so what we've done is we started off with all the income of all the factors of production, and then we realized that some of that income gets diverted other places, doesn't come to the household, so it's not received. And then income from all sources, whether earned or not, there's a little bit of income that I might have or you might have that you didn't earn. It just comes in the mail, and thank you very much. Transfer payments. So there we go, is personal income. And finally, it's almost finally. It is finally in a sense, and yet in another sense it's not. Disposable income. This is income that the individual or the household has to spend. Spendable income. Spendable income. And that's equal to personal income minus Personal income, that's income received. So all the income you receive minus personal taxes that tells us our disposable income. After you pay your taxes at the end of the year, what you're left with out of your personal income, that would be your disposable income. That disposable income can be used in two ways. Disposable income, it's used in two ways. One is consumption, spending, and the other is saving. This is your spendable income. It's your income after all your taxes are paid, and you can do whatever you want with it, and the answer is anything you want to do with it's two things. One is you can spend it, or the other one is don't spend it, and if you don't, we call that saving. Sometimes, where will I write this? Right over here. We hear something called the saving rate. And that's equal to saving divided by disposable income. So that is the percent of that disposable income, or that you might call it take-home income. The percent of your take-home income that you save, that's your saving rate. Questions about that? In general, here's what happens. Gross domestic product's the biggest number, and then we subtract a fairly small amount from that, this depreciation. And I don't mean to say it's nothing. It's a huge amount compared to what I have or Springfield has, but anyway, it's a fairly small number so that we're left with net domestic product. It's almost as big as GDP. National income, well, it's a little bit smaller than net domestic product, but not a whole lot smaller. Personal income, you know, personal income has got these, it's national income minus a few things, but then plus a few things. That one thing in particular is transfer payments. Personal income could be bigger than national income. These things are not all that far apart in terms of their size. You go, personal income is equal to national income minus three things plus one thing. And I'm saying these three are about the same size as that one, ballpark numbers. And so there's not a big difference between the size of national income and the size of personal income. Then personal income is bigger than disposable income because disposable income equals personal income minus some taxes. Well, the taxes are always a positive number, so it's always the case that personal income minus taxes is going to leave you with a smaller number. And by the way, you can tell that with your paycheck, you know, your take-home pay is you always start off with your personal income, and then it subtracts out your taxes, and you're left with a smaller amount to take home. And then your disposable income minus your consumption, that's how much you save. This saving rate for many people is, oh gosh, I don't know, 4%, 6%. For a lot of people, it's in that range. For the U.S. economy as a whole, it's been even lower than that. 2%, 1%. So not very much saving taking place in the United States. Now why is that? And the answer is, in recent years, people haven't been saving very much. That is to say, let me come back to this. People have been spending most all of their disposable income and been saving a small amount. And why is that? And the answer is because the stock market has been very strong in recent years. And when the stock market's going up, then people gain. And when they gain, they say, wow, my savings went up. Well, they don't mean savings the way we're talking about it here. They mean all that stuff I've accumulated in the past. I saved, let's just pick out a number. I saved $50,000 in the past, and this year the stock market went up 20%. And so $50,000 worth of saving and a 20% gain, I gained $10,000 during the year in the stock market. And if I gain $10,000 a year in the stock market, I start thinking, gosh, my savings have built up. They were at $50,000, they went up to $60,000. That's like me saving $10,000. And so in recent years, people have been letting the stock market go up and been pulling for it to go up, but they've been letting that go up, and so then, as a result, they don't save very much out of their current income. If the stock market didn't go up year after year after year, then people would start thinking, gosh, if I want to reach my retirement plans and so forth, I better start putting some savings away, and then this saving rate would rise. But anyway, what I'm telling you is there's more going on than just what we're talking about in this picture. The more going on is what's happening to asset values and so forth. Some people, of course, save a very large amount. Others don't save very much at all. I would encourage all of you to save a large amount. And by the way, the sooner you start saving, the better it is. We talked about that rule of 72 before. And what that rule of 72, let me just give you an example here. Suppose that your rate of return is 12% in the stock market, and I'll just sort of pick this 12% number out. Then T equals, what would that be, 6. Every 6 years, you double your money. Right? Well, what do we see here? Suppose that you put away $1,000 and your age is 20. Age. So what I'm saying is that 6 years later, when you're 26, you've got $2,000. That's if you don't save anything more, but you just had this 12% gain year after year, and then you've doubled your money at age 26. And then at age 32, when you're 6 years older, you got $4,000. When you're age 38, 6 years older, you got $8,000. 44, $16,000. 50, $32,000. I'll put a K up there. I'm getting tired of making those zeros. 56, this is $64,000. 62, isn't that 6? Yes, it is. $128,000. 68, retirement age, $256,000. That's really a long ways to come. I mean, you put $1,000 away and forget it. And then time starts passing, and you might go, boy, 68, that's a long time. Yeah, that's about when you'll be retiring, though. So you've got the time. What else, where are you going to go? You've got to wait, so you wait for those 48 years, and that $1,000 turns into $256,000. But the real key is start early. Because if you started saving when you were, let's say, I'll just pick something out here. Let's say you started saving when you're 44. You put $1,000 away, and then it's $2,000, $4,000, $8,000, $16,000. Now, what would you rather have, $256,000 or $16,000? And the answer is, that's not a very smart question. Obviously, you'd rather have $256,000 as $16,000. But this is such a vast difference. And it makes all the difference in the world when you start saving. Did you start when you were 20, or did you start when you were 40, 44? I've done these numbers before. When you start off at 0, suppose that you put $1,000 away, and gosh, then it doubles a few more times, about 3 more times. So this becomes $500,000, $1 million, $1 million, and then $2 million. So vast amounts can be saved, but you need to start early, and that's why I took a minute here in class, is to encourage you to do that. If you don't have anything saved, put something away in the stock market, find a good diversified mutual fund, put your money there, and then forget it. Don't be going back and touching it going, oh, I need to have a new car. If you need to have a new car, then make arrangements to get the new car. If you can't afford payments, don't buy it, but don't touch that money. It's going to double every 6 years for you. Okay. Last couple points that we want to make today. What we have, and we're finishing up this material now that we've been talking about. What we've done in this unit of material is we've talked about 3 variables. We talked about the consumer price index. We talked about the unemployment rate. And we've talked about gross domestic product, or I should say, and real gross domestic product. That's what we've talked about. Let's talk about what policymakers like and what Americans like, and really not just Americans, people overseas. But what do people like? Here's what they prefer. They like stable prices. So, and let me just write that slightly different. Here's the goal: price stability. The goal of policymakers and the goal of most Americans is we don't like inflation. We like sort of a stable price level. That does not mean every price stays the same year after year. What it means is this, is that the average price level stays the same year after year. Some prices are going up, some prices are going down, but the average doesn't go anywhere. That's the goal. Unemployment rate, low. We like that to be low, about 4 to 5%. That's the natural rate of unemployment. That's our goal. We like to have the unemployment rate at about the natural rate. That is to say, we like to say there's full employment. And with respect to real gross domestic product, we like to have some growth. About 2.5% to 3% per year. And I'm saying now the real, not nominal gross domestic product. Nominal gross domestic product is what's happening on the real side of the economy, production, but it also includes an inflationary thing. So if we have price stability, no inflation, and we've got the real GDP growing 2.5% or 3% a year, nominal GDP would go up by that same 2.5% or 3%. Those are the goals of policymakers. Now, what we're going to do for the rest of the semester is we're going to talk about how policymakers make this happen. What can they do to bring this to pass? If you remember what we talked about before, and let me just kind of put those up again, is we've got the household sector and we had the business sector. And if you remember, we had businesses producing goods and services. And then we had households paying for those goods and services. What you could think of this as, and by the way, there was more to that model, but what you can think of this as, here's the goods going from businesses to households, here's the dollars coming back in return. You can think of the dollars as the demand side of the economy, and you can think of the production as the supply side of the economy. So what we want to do in the rest of the semester is we want to understand the demand side of the economy, the supply side of the economy, and how those things interact to influence the consumer price index and the unemployment rate and GDP. And once we understand how the demand and supply side of the economy determine the inflation rate, the unemployment rate, and GDP, then the next step will be how do policymakers control their policies to influence these variables. And that is the next unit of material. That's where we'll start next time. So long.